One burst tire ruptured 3 fuel tanks and grounded supersonic flight for a generation. If you picture jet crashes as engine failures, you're missing the real killer here, a strip of rubber. It took 90 seconds. Concorde was the only passenger jet that ever cruised at twice the speed of sound. New York to London in about 3.5 hours. Then in 2003, it stopped. Commercial flying actually got slower and has stayed slower for more than 20 years. No jet has matched it since. So how did one tire end an entire generation of supersonic travel? Start with what Mach 2 actually costs to reach. That's about 1,350 miles per hour, roughly 2,180 kilometers per hour. To go that fast, Concorde didn't fly where normal jets fly. It climbed to around 60,000 feet, nearly double a typical airliner's cruise. Up there the air is thin, and thin air means less drag holding you back. But thin air also gives your wings less to grip, so the whole shape of the plane had to change. Ordinary wings would tear the aircraft apart at that speed. Concorde used a slender delta wing, a long triangle that stays stable when the air itself is slamming past. Here's the part people forget. Reaching Mach 2 is one thing. Staying there for hours is another. Its engines could light afterburners, dumping extra fuel into the exhaust for a huge shove. Not just for a quick dash, but to push through the sound barrier and then hold supersonic cruise the whole way across the ocean. And going that fast heats the metal. Friction with the air warmed the skin to about 127 degrees Celsius. Hot enough to burn your hand. The aluminum body expanded as it heated, and the entire fuselage physically stretched several inches in flight. Pilots reported a gap opening on the flight deck you could slide your hand into. When it cooled on the ground, it shrank back. So this was a machine living at the edge of what its own materials could survive. Stretching, baking, screaming along at a mile every few seconds. Beautiful. Also brutally demanding. And all of that speed and heat had a price nobody could hide, one that shows up the moment you look at the fuel. Which raises the real question, where did all that fuel go? Here's where it gets expensive. Pushing past the sound barrier isn't like driving faster on a highway. As you approach the speed of sound, the air can't get out of your way fast enough. It piles up into a shockwave, and shoving through that wall costs enormous energy. Engineers call that extra resistance wave drag. The price of breaking through, paid in fuel every second you're supersonic. And Concorde paid it the entire flight. The numbers are staggering. Crossing from New York to London, it burned roughly a ton of fuel for each passenger on board. 1 ton per seat for a single trip. But the fuel wasn't just sitting there being burned. It had a second job. When a plane goes supersonic, the point where its lift balances shifts backward along the wing. Left alone, that would tip the nose up and make it unflyable. So Concorde solved it by moving weight. Crews pumped tons of fuel between tanks in the wings and tail during flight, sliding the aircraft's balance point backward to match the shifting lift, then forward again to slow down. The fuel was ballast, coolant, and power all at once. Now picture where all that fuel had to live. To carry enough for a supersonic Atlantic crossing, the wings and the belly of the plane were packed with tanks. Thin-skinned tanks spread across exactly the surfaces most exposed to the runway below. Every drop of that engineering made Concorde fast. And every one of those tanks, sitting right under the wing, quietly became the weakness that one bad day would find. So what happens when something hits them? Now the one bad day. July 25, 2000. Air France Flight 4590 rolls down the runway at Paris Charles de Gaulle, fully loaded, accelerating toward takeoff. What nobody knew, minutes earlier, another aircraft, a DC-10, had departed from that same runway and shed a thin strip of titanium from one of its engines. That metal strip, maybe 16 inches long, was lying on the tarmac directly in Concorde's path. Here's the chain link by link. At high speed, one of Concorde's tires ran straight over that titanium strip. The strip sliced the tire open, and the tire didn't just deflate. It exploded. A chunk of rubber weighing around 4.5 kilograms, think a heavy bowling ball of tire, was hurled upward at enormous speed into the underside of the wing. And here's the detail that surprises even engineers. That rubber chunk did not punch a hole in the fuel tank. It never pierced the metal. Instead, it slammed into the full tank from outside like a hammer hitting a water bottle. The tank was completely full of fuel, and fuel doesn't compress. So the impact sent a pressure shockwave racing through the liquid inside, and that internal wave blew the tank open from the inside. rupturing it along a seam and tearing a hole far bigger than the rubber ever could. Fuel poured out in a sheet. Stop and picture that. A tire. A piece of another plane's engine. No fire yet. Just hundreds of pounds of jet fuel gushing from a wing at the worst possible instant. A plane already committed to takeoff and too fast to stop. What could possibly light it? The fuel found its spark almost instantly. Investigators believe it ignited from either severed electrical wiring the fragment cut, or the raw heat of the engine right beside the leak. Either way, a wall of flame erupted and trailed behind the aircraft. A fire longer than the plane itself streaming off the wing. Now the plane is fighting for its life. 2 of its 4 engines lost power in the chaos, starved and damaged. And this is the cruel part. Concorde was already past the speed where the crew could safely abort. Too fast to stop on the remaining runway, but crippled and burning. With half its thrust gone and a delta wing that needs speed to make lift, it simply could not climb or accelerate the way it had to. It staggered into the air barely above the ground, mushing along, unable to gain height. It stayed airborne for roughly 90 seconds. Then it came down on a small hotel in Gonesse, just outside Paris. Everyone on board, 109 people, was killed, along with 4 people on the ground. Here is what makes this crash different from almost any other. In nearly 3 decades of flying, this was Concorde's only fatal crash. 1. The plane had a spotless record right up to that afternoon. But spotless is a fragile thing. It only stays spotless until the day it doesn't. And when that day came, it didn't just take a plane. It cracked something you can't repair with rivets, the belief that this machine was safe. So they grounded the fleet. Could they fix it? And here's the twist, they did fix it. The engineering answer came fast and it worked. They lined the fuel tanks with Kevlar, the same tough fabric used in body armor, so a fragment couldn't rupture them the same way again. They fitted new burst-resistant tires designed not to shed heavy chunks. They armored the wiring the fragment had cut. On paper, the exact accident that brought it down could not happen twice. So if the plane was fixed, why did it still die? Because the tire was never really the problem. The problem was the maths. Only 14 Concordes ever flew. That's the entire fleet ever built. 14. Spare parts for a machine that rare are astronomically expensive, and the airframes were now decades old and tiring out. Fuel prices were high, and remember, this thing drank a ton per passenger. Then came 2001. After the September 11th attacks, air travel collapsed in premium travel. The wealthy passengers who filled those expensive seats collapsed hardest of all. The seats that paid for everything sat empty. And the final blow was quiet and technical. Airbus, which supported the aircraft, decided to stop maintaining it. Without the manufacturer keeping it airworthy, the fleet's clock ran out. So the crash didn't destroy Concorde by itself. It shattered the plane's flawless image at the exact moment the business underneath. It was already too fragile to take the hit. What tipped it over the edge? So here's the whole picture clicking together. In October 2003, Concorde flew its last paying passengers and retired for good. And now the paradox from the start makes sense. It was never really one tire. That tire was the trigger, but the gun was already loaded. Look back at everything that made Concorde magnificent. The fuel-packed delta wing that let it cruise at Mach 2. That same wing put thin tanks right where a runway fragment could find them. The tiny fleet and razor-thin economics that made every flight feel special. They left zero cushion when trouble came. Every single trait that made this plane fast and extraordinary also made it fragile and ruinously expensive to keep flying. A sturdier, cheaper, more ordinary jet would have survived a burst tire and a bad year. Concorde couldn't because it was living at the edge of everything. The edge of physics, the edge of its materials, the edge of its own budget. One fragment of rubber didn't have to destroy it. It just had to push once, and the whole beautiful, brittle thing tipped over. And the promise I made you at the very start. 20 years on, we still haven't built anything to replace it. We chose to fly slower. One fragment of tire exposed how brittle the entire supersonic dream really was. Fast, dazzling, and balanced on a knife's edge. But the dream didn't die completely. A new wave of startups is trying to bring supersonic passenger flight back, betting they can fix the economics Concorde never could. Can they actually pull it off? That's the next mechanism we'll open. Subscribe and find out.